Hi there, I'm Kieran Higgs from TDR Electronics, and if you're like me, you seem to spend a lot of your time debugging failed PCBs. And one of the most important tools you need to carry out this task is a very good schematic. Sadly, most of the time you're just given paper copies of schematics, and it makes the job very difficult. And why is this? If the circuit's quite simple, a paper schematic ain't a problem. But this particular circuit we're looking at here, as you can see, it's spread over 27 pages, and I can assure you there's over 950 components. So, if you're looking for a component on a paper schematic, as you can imagine, it will take you a long time. Um, you might be lucky to have searchable PDFs on your works computer, but unfortunately they only take it to so far. Unfortunately, the problem is if you're looking for, I don't know, C3 for example, you'll have to bring up the find box, type in C3 and hit go. If C3 is on page 20 and you're on page 1, it might find C30, C31, C32 long before it gets to C3. As you can see, this could take a long time. Unfortunately, you can't type C3 and then a space, as that won't work. So, this particular PDF is generated from orcad schematic capture. I use orcad schematic capture in my day-to-day jobs, but sometimes you just can't go with your schematic capture, so it's a lot easier just to take a PDF. This PDF has got some really good features, and I'll talk you through them now. So the first thing you see over here, we have bookmarks. This particular design is done in a hierarchical design. So as you can see, we zoom in a bit. You can see there's various blocks. So you can click on the block and descend to that block later on. You can pull out all the blocks, see all the blocks, so all the ones that's in dark text is obviously your block, and then there's obviously pages underneath it. Just because every one of these is page 1, that's page 1 for that particular block. So you can click on that and it will take us to this block. Okay, so the next, let's close that one up. The next one we see is reference designators. Now this might be of interest to you guys. If you're looking for C3, just open it up and just search down there. Unfortunately, it does C1, C10, C100, C101, C102 and so on. So, but it don't take you long to find. There you go, C3. I've gone too far. There you go, C3. So I can click on C3 and it will take me to C3. And then of course you can zoom in or zoom out and find out what block this is. I'm still working on this circuit, so I haven't put any information down here what block it is, but that's to be remedied. The last bit, and this would come in useful if you're working on a test machine, a bed of nails type test machine. So you're doing a board test, so it checks to make sure that solderability is good, i.e. The component is properly soldered to the board. It does this by obviously injecting small amounts of current, checks for resistance. Now if it comes up with a short, it might say there's a short between I don't know, 5 volt and 0 volt, and if you want to see what components are connected to those nets, here's, this one's for the 15 volt, and there's all those components that's connected to the 15 volt. As you can see, there's quite a lot of them, as you would expect. 5 volt, 15, and these are all just ordinary nets. So, and then that will actually take you to that net. Now, one thing that you would also find useful as a PCB repair specialist is if you're looking at a circuit diagram such as this one we see here. By the way, I've still got some work on it as there's still parts of components that ain't connected. So you go to the end here and you see this component here. You don't know what it is, you don't recognise that part number. So what you do, so most people would copy this part number, go on Google, search the net and download a datasheet for it. But that's another document you've got to manually look after. Wouldn't it be easy if you can just click on it like that, go down the menu and find where it says datasheet, click on the datasheet and that pulls up the datasheet. Wouldn't that be easy? This sort of work has made my life a lot easier. This can only be done in orcad, and incidentally we can have the same functionality in orcad. We can click on a component in orcad and it will pull up the datasheet without you having to go through your network hierarchy and go to the right directory and find the right datasheet. It all just makes the life so much easier. If you as an organisation want PDFs like this and you don't want to buy orcad capture or the orcad development suite, it is an expensive tool, I understand. You can always ask me a comment. So orcad will import Altium, Eagle and Mental Pads. If there's any tool that it doesn't import, you might be using, I don't know, KiCad for example. If you're using KiCad or KiCad or whatever it's pronounced as, you can ask me and come in. I will take the KiCad design and I will put it into an orcad format design. This obviously takes a lot longer as I've got to actually recreate the design from your original KiCad files, and it takes a long time. So the orcad design software I've got is actually the latest version, and it's protected by a dongle, so I can install the software on your machines without having any penalties from Cadence, which is the people that owns orcad. All the while the dongles fit your machine, the software will run. The minute I take the dongle out, the software will stop running. Now I'll have to reinstall the dongle next time, and so we can carry on working. Hopefully that makes sense, and hopefully you can see the advantages of this type of schematic PDF will have for your debug team, and I look forward to hearing calls from you. Thank you very much.